The Next Generation Science Standards lists 8 practices that professional scientists and engineers use in their everyday activities. These practices are also important for us to use in our classroom as we're teaching children about science and engineering. The first practice is asking the right question, and I actually believe that's the most important practice because the rest almost become trivial if you don't ask the right question. The interesting thing with this first practice is that the questions that scientists ask and the questions that engineers ask are quite different. There's a difference. A scientist is interested in understanding a phenomena, and an engineer is interested in understanding a solution. And so, for example, with a scientist, it might be something as trivial as what happens to an ice cube when it melts? How do I understand this phenomenon of melting? Or something even more profound, what are the conditions for a tornado? Can I understand how a tornado builds its energy up or depletes its energy at different spots on the earth? Those are fundamental understandings. An engineer is seeking a solution to a societal problem. So the engineer's questions are related to design. It might be something as simple as, how steep should the incline be so that when the marble rolls down it'll trigger this other event? Or how can I make a shoe where the sole lasts longer and is very comfortable? Or if I'm designing a shopping bag for a grocery store, how strong does the handle have to be in order to carry a gallon of milk and some other things? And what kind of glue should be used for that handle? What's the strongest possible thing that I could do for that shopping bag that would make it attractive and sturdy enough to carry out this task? Those are the questions the engineers ask. The questions the scientists ask are about phenomena. The questions the engineers ask are about a solution.